When a metal cation forms multiple charges, you'll see this periodic table throughout this video a lot. It is a handy tool to have. If you don't have access to it via D2L, go ahead and grab a screenshot, have it on your phone, have it in your lab notebook, whatever it is that you need to have this, because this is a powerful tool for being able to figure out charges when we're talking about multiple charges. So first and foremost, let's talk about the stock system. The stock system is nothing more than a system that we use to name ions that form multiple or variable charges. Multiple and variable charges mean the same thing. They mean it just or more than one charge. And you might hear them referred to as a couple of different things throughout your chemistry labs and lectures. So I just like to throw that out there. So the way that we work, the way that we name these things is we're using the element name, and then we put their charge in Roman numerals in parentheses, and then we follow it up with the word ion. So again, like I said, you're going to see this periodic table a lot. Make sure you have a copy, all the things. Now, before we get started on our first example, I'm going to remind you, we're just using the element name, we're putting the charge in Roman numerals, and we're following it up with the word ion. So let's do the first one. This is an iron ion, and it's got a +2 charge. Now, if you will look down at the periodic chart, you will see where iron can carry a +2 charge or a +3 charge. And so it's variable, right? This one is a 2 because the charge tells me that it is a 2, and that's why we name it that way. Then we have a iron that has a variable charge. It is a +3. So when we name that, we're going to name that an iron 3 ion. And I know that it's iron 3 because it is a positive charge. All right, so I like to keep this periodic table close and just remind you we're naming them with the element name, your charge in Roman numerals, and we're following it up with the word ion. So right here we have Pb. Pb is lead. If you look on your periodic table, lead carries a +2 or a +4 charge. So this one has a +2 charge, and that means what we have is a lead 2 ion. That 2 that is in the parentheses in Roman numerals comes from the actual charge. Then we have the second one, just a quick overview. We have a lead, it's a +4 charge, and so that means that we're going to end up with a lead 4 ion. And again, our Roman numeral comes from the actual charge. You know, I do love this periodic table. It's actually a great, fantastic tool. Let's do one more. We're going to do copper. So look on your periodic table. Copper carries a multiple or variable charge. It could be a +1. Now notice there's not a 1 in front of that plus on the periodic chart. We are understanding that as 1 when it's just a positive sign. So it can carry a +1 or a +2 charge. And what do we have here? We have a +1 charge, and that gives us copper 1 ion. And again, our Roman numeral comes from our charge. And so of course, we're going to do it again. We have a +2 charge, and that's going to give us copper 2 ion. And again, the Roman numeral comes from the charge. So let's go through a quick example and show you what we're working with. I love this periodic chart. Use the charge on the anion to determine the overall negative charge. So we want to focus on the anion first. Here we have a nickel bromide, okay, a nickel bromide. And what I really want to concentrate on first is the anion, which is my negative charged atom. So bromine on your periodic table has a -1 charge. Bromine, it is a -1 charge, which makes it a bromide. Now, if you're confused about why we're changing the suffix, there are other videos in your video library you might want to check out. Mainly, maybe you want to see naming monoatomic and polyatomic ions. So, bromine has a -1 charge, but we have 2 bromines. So we have a -2 overall charge because -1 times 2 is -2. This is going to be our overall negative charge. Now, the overall positive charge has to equal the overall negative charge in order to have a neutral compound. And if you're confused about neutral compounds, there's definitely videos in that video library that can help you. Namely, chemical formulas and names from individual ions might be a good place to start in the video library if you're confused about that. But let's focus on the one we were just working on, which is that NiBr2, and we've already figured out that our bromide has a -2 charge because it has a -1 on that periodic chart, but there are 2 of them. Okay, so let's go back to our cation. Our cation is our element with our positive charge. And if we have the cation, we know, if you look right here, it is a +2. Okay, and so that we know if nickel has a +2 charge, there's only one of them, then that is going to be your overall charge for your nickel. Okay, so that means, because we are right here in these transition metals, that your nickel will have the parentheses with the 2 because it is our cation and it is our transition metal. Okay, so if we put it all together, we have a nickel, which is a +2. That's our nickel 2 ion. And then we have a bromide, and that is going to be a -2. Remember, it is a negative charge, but there's 2 of them, so that is a bromide ion. And we're just going to take and get rid of the word ion, and our final answer is going to be nickel 2 bromide. Nickel 2 bromide. All right, another quick example. We're going to use the charge on the anion, remember, to determine the overall negative charge. So that is our first step when we're doing these problems. Right here, I want to show you the difference between a number being on the outside of a parenthesis and the number being on the inside of the parenthesis. So what you have here is a polyatomic ion. That polyatomic ion is SO4. There are 3 of those SO4s. So that's why that 3 is outside of the parentheses. It's telling you there are 3 of those compounds together, okay? And I want to make sure you understand that. These are called subscripts. So if you go to your polyatomic ion sheet, you'll find that SO4 has a -2 charge, and there are 3 of them. So if there are 3 of them, and it has a -2 charge, we're going to take that -2 charge, multiply it by 3. So that means our SO4 3 is a -6 charge. That is going to be our overall negative charge is a -6. Now, this is our original problem, so I just wanted to bring it back to you, okay? There are 2 iron atoms, and that's what that subscript means next to that 2. It is on the, it has nothing to do with what we're doing with that polyatomic ion, right? So there are 2 iron atoms, and so each one has to be a +3 in order to make the compound neutral. Our goal is to make that compound neutral, right? So we have an Fe +3. If we have an Fe +3, I have an iron 3 ion. And if we look down on the periodic table, we see that iron can carry a +2 or a +3 charge. Now we know that we're using our +3 charge because there are 2 iron atoms, and we need to have a +6 charge for our cation in order to neutralize our compound from the anion, which was a -6 charge. Okay, so if we have the Fe +3, that's an iron 3 ion, and then of course we have our polyatomic ion, which is a sulfate ion. If you combine those together, drop off that word ion, your answer, final answer, is going to be an iron 3 sulfate. That is your final answer. Any questions that you have should be directed to your instructor. You can take a screenshot of this periodic table, look it up on the internet. You can find something that you like that's easy to use. I really like this one because of the colors. It breaks them apart. And I see like the single charges also, which can be important when you're working on these problems. I hope this video has helped you out in the ways of multiple charges. Please direct any questions that you have to your instructor.